So, today we will study drilling and topsides, and there are some features for the which is to be noted for the floating platforms. So, here you can see I have drawn a semi-submersible. This is a drill ship, not a semi-submersible. This is a floating platform. Now, floating platform there are a number of points to be remembered when you are drilling. One is that the marine riser will have lot of motions. Now, in order to accommodate that those motions such that the marine riser does not rupture or break, then you have to have number of joints, as you can see from this figure. And what is to be noted out here is the blowout preventer assembly is located on the seabed, just on top of your wellhead. So, your wellhead will come somewhere here. On top you will have the BOP stack, and this is resting on the seabed. So, this is your seabed, right. Now, this is your marine riser. And this is your water line. The drill ship is floating. The marine riser or the conductor pipe has to be kept taut. That is the fundamental requirement. Otherwise, there is going to be an undesirable sag in the riser. So, here you have to have buoyancy tanks. Or it is called buoyancy modules. So, in the figure I have shown only one, but there may be more than one according to the weight. So, now the drill string, actually, that is your drill pipe will go pass through the marine riser down to the wellhead. This is your wellhead. Or sometimes this is called wellhead assembly. So, this is a suspension point for your casings. This is suspension point for casing string. So, this is resting on the seabed, and here the BOP stack. So, while drilling, this is called a blowout preventer assembly, and after drilling is complete, this is called a production Christmas tree. So, that is placed on your wellhead. So, first what is done, this wellhead is lowered from the drill ship onto the requisite site, then it is placed by gravity anchors, or sometimes this is also piled, but piling underwater is difficult. Okay. So, this is fixed to the seabed, and then you connect the marine riser to the BOP by means of slings or strings from the drill ship. So, here this BOP is this one, and this one is a ball joint. You can make the correction actually on my drawing. This is a ball joint. So, there will be a lot of motions coming from the drill ship onto the marine riser. So, those have to be accommodated by number of joints. So, at the drill ship end you have a slip joint. And just below it you have another ball joint. So, ball joint is a universal joint, whereas a slip joint will just allow you motion in one direction. And the other point that is to be noted is a tensioning device on the whole of the marine riser, that is given by a heave compensating device. So, I have not, this is a winch actually. So, this is a heave compensating device. So, these are some of the salient features for afloat. This is called afloat drilling. Your notebook. This is called afloat drilling. Now, in the afloat condition, I told you have lot of problems coming from ship motions. So, motions has to be accommodated by joints and the universal joints, and buoyancy modules are given also to give the upward force on the marine riser in order to support the weight. So, this is your diagram. Now, the other point that is to be noted is the riser. The riser actually, I told you, it comes in lengths between 30 and 40 feet, 30 to 40 feet length. Diameter you can write, diameter varies. So, diameter is from 400 to 1060 millimeter. So, this is made of forged weldable steel. So, these are the materials of the riser, and my riser is nothing but a conductor pipe, and inside the drill string will be going on. Now, actually you can drill number of wells because of the technique which is called deviational drilling. So, in a deviational drilling mode, you can drill number of wells from the same vessel. So, in my notes, I think you have studied 13 directional wells can be drilled. By insertion of wedges, onto the seabed. So, that means you have to drive a wedge at this, say your drill string is coming out here, you have to drive a wedge through which it will pass. So, those things are quite complicated anyway, but you can do it. So, this is one head, serves as a casing. Drilling is done from drill ships. Now, in the drill ship you will find, if you look at the general arrangement drawing, now I told you last class that the moorings of these vessels are very important. So, after your exams I will talk about this mooring lines. So, you have this kind of, this is called a spread mooring system. Spread mooring, and on the other end you have gravity anchors. Now, on top of that also I talked about the DP system, that is your directional positioning system. You can have one or two thrusters at the forward or at the aft end. So, these are called DP system. So, these are automatic, according to the motion of the vessel you can position. So, this is called a thruster. So, motion control is a must in all these in your afloat condition. So, motion control. Motion control critical in afloat drilling. Now, after your exploratory drilling is over, then you go for production development drilling. Now, after this I will talk about topsides, and you find that if you have to accommodate both, that is exploratory as well as production, you are going to make things complicated, and according to that you have to size your platform and general management drawing. So, that is will be possible. Now, drill ships normally they are not used for your production operations. So, drill ships you will find they are more suitable for exploratory drilling, but productions you will find they are mostly done from TLPs and semi-submersibles. So, here you will find that the deviational drilling also can be taking place, but the basic requirement is the platform. So, this I will talk now. What is the platform doing? So, this provides number one, working deck. This we will discuss in detail when I talk about the general management. So, working deck for production drilling. Number two, basically housing for processing, and segregation. So, this is in a nutshell the equipments that are required: segregation of oil and gas, so this is, then you have to have storage facilities. Number three is oil storage. Then you have gas disposal. And then you have the other items, that is pumps, compressors, etc. Now, this I will discuss a little bit in detail in the GA configuration or in the GA drawing. So, that brings us to the end of this drilling. So, what is to be understood is the other points that you will come across is in production development is objectives in production development. So, you can see actually your exploratory drilling and production drilling, they are two separate entities altogether, and there are a number of points which are to be taken care of in the production stage. Now, here you will find that number one is what you have to in production drilling is fewest wells. Now, you increase do not increase the number of wells. So, that will create problem in the floaters. Floaters means your drill ship or your semi-submersible, and that is also not economic. So, you try to find out the fewest wells with efficient production of so that means you have to strike at a economical flow rate in terms of barrels per day. So, efficient production of oil obviously come with oil and gas. So those have to be separated. Now number 2 is drill, complete and equip wells at lowest possible cost. Now what is done, because there is a time factor, you are drilling say number of wells from the same platform. So obviously it will take number of months, isn't it, to complete the drilling process. So the client is not ready to wait for such a long time. So there is a simultaneous production of oil is also taking place from the platform. So you drill, complete the well and equip wells at lowest possible cost, and this has to be done simultaneously. So this reduces, so offshore drilling and offshore production is more expensive than onshore location. So that is why all these things have to be, features have to be taken care of, reduce both capital and operating cost. So this has to be done. Now the last one is you recover largest possible volume of oil and gas. Gas, normally you will find the volume is given in cubic feet at a certain pressure, and barrels are the capacity for the oil. So this has to be done, that is recovery of the largest possible volume of oil and gas. So this is normally done by what is called steam injection into the oil reservoir. So in the conductor pipe, from some of the conductor pipes will be carrying your oil and gas to the platform, and the other pipes will be carrying steam and mud. So mud circulation has to be maintained, and also steam injection has to be done to recover the largest possible volume of oil and gas. So these are some of the objectives in drilling, or what is called your production development drilling. Now let us go to the another very important topic, that is called topsides, or rather you call it topside layout. Now this is similar to your general arrangement drawing for ships, but the problem is the offshore platforms are not ship shaped, isn't it? So offshore platforms are rarely ship shaped, and their mission requirement or design requirement is different. So offshore platforms, so this is where your basic difference will come from ships. So offshore platforms design different from ships. In some cases, some of the factors may have similarity, design different from ships. So now how you are going to design them? So this is your fundamental difference. So these offshore platforms are normally deck supported structure. Platforms are normally, they are called deck loaded structures. So, your main activity is on the deck. So, major activity is on deck. So, this has to be designed. So, your first design is the supporting structure, that is the underwater truss, which I have already talked about, which you have to design from environmental loads. The next first is your underwater truss. Now, this is very crucial. So, this has to take care of take on the wave loads. Primary load is your wave load. Third, and other loads are there, current, wind and all these things are there. Now, number 2 is deck design. So, these are actually distinctly different from your ship design. Now, ships, if you look at say oil tankers or cargo ships, they are not deck design vessels. That means, you do not have any deck activity as such, isn't it? So, what is the main activity of a cargo ship or a oil tanker? So, ships that are normally that you have designed are primarily centered around carriage of cargo. Okay, this is where ships are radically different from offshore platforms. Now, offshore platforms, if you design, so they are basically centered around the process of drilling and recovery of oil and gas. From reservoir. So, this is the primary, what is called the mission requirement difference between a cargo ship and a offshore platform. So, your mission requirement or design requirement is different. Okay. So, based on that you have to design. Now, the another point, so I told you start or design. There are two important structures that have to be designed. One is the underwater truss and the deck design. Okay. Now, underwater truss I have talked about, we will come back to that later on. So, here the deck layout. Now, deck is basically a supporting structure for what? Supporting structure for deck modules. Now, the whole concept of design is actually centered around what type of these deck modules you are going to. So, here actually the topsides are given, you can have a look. So, they basically designed centered around this deck modules, and for that actually you have two types of decks. One is called, there are basically two types of decks you will come. Or rather you write two types of deck construction. Now, if you happen to visit one of these offshore companies, then you can see this. So, number one, this is called integrated deck. And number two, it is called modular deck. So, these you come across in offshore. If you go platforms, you will basically see these two types of deck construction. One is called the integrated deck design and the other is called the modular deck design. Okay. Now, when you go for integrated deck and when you go for modular deck. Now, offshore structure, see, offshore structure is basically different from ships, isn't it? Now, ships, how they are constructed? Ships also, nowadays ships are also built in segments. Ships are normally built in segments. Now, this in technical terms, this is called a weldment, isn't it? Weldment in where? In hull shop. So, if you go to hull shop at the end of third year, you can see the ship, that is part of the vessels are being built and then they are joined and welded. Now, whereas your offshore structures normally the underwater portion, that is the underwater truss is built separately from the deck. You do not build the truss along with the deck as in ships. Okay. So, here truss offshore structures. So, truss and deck built separately. In most cases or in none of the cases you will find truss is built along with the deck. So, they are built separately and the trusses are normally built in the horizontal. I gave you the diagram in your previous class. They are built horizontally on the graving dock and then they are appended etc., and then they are welded. So, they are built in panels. Their trusses are normally built as flat panels. Flat panels in what is called graving dock. Now, I am discussing a little bit of this. Why? Because your design of the platform design now you are basically engineers. Okay, you have to do some design work. We are employed in one of these offshore companies. Now, platform design has to take care of these two processes. Whenever you design a engineering object, now a ship or a offshore structure, they are very large objects. Take care of installation process, installation and erection processes. This is very important in offshore structure design, because part of the installation will take place in the water. The installation in land, like ships, most of the ship is actually built in your slipway or the graving dock. You are out of water, but here actually I told you, for large or tall offshore structures, part of the structures are lowered onto the seabed and then it is positioned and then welded. More difficult task. So, this installation and erection process is of paramount importance for offshore structures, and these are also related to your structural stresses coming to the platform. Remember this. So, before you start any novel design, so there are a number of designs of offshore platforms which I have showed you. Now, there is a large element of risk involved in these platforms. So, normally these platforms are built by experienced contractors, big oil companies. They go in for this because novel designs, when you go, then you do not know all this, no? Installation, what are the problems you will face and all that is unknown. So, the designers, they always prefer to work in known territory rather than the unknown. First thing is because of the huge amount of capital cost that is involved in the construction and design of these platforms. So, there the problems will come up there. So, anyway, next coming to this, there are certain layout which is called layout, or rather general layout considerations. General layout considerations are this GA of the deck. I am talking about the deck, layout considerations of deck. So, this I have already talked about, that is the integrated deck and the modular deck. Now, these offshore platforms, their overriding factor is what? Now, in what way this is offshore platform design is different from your cargo ships? Whenever you go for design of offshore platforms, tankers, etc., your prime consideration will be safety. Because you are dealing with oil, because of what? Fire, because of fire from oil. So, whenever you are dealing with this oil or natural gas, your design requirements become more complicated and requires more thorough inspection also. So, that is why offshore platforms are investigated or designed approved by number of agencies. Or rather, you write number of certifying agencies, and they prescribe the minimum design requirements. Now, one of the prime agencies they certify is the API code. API code has to be followed in case of offshore structure design. The American Petroleum Institute code for design. There are a number of designs. One is pipelines, structures, etc. will come under this code. Then you have ABS. API full form stands for American Petroleum Institute. Now, if your platform happens to be positioned in Gulf of Mexico, then you have to follow this code. ABS you all know or should be knowing, there is American Bureau of Shipping, which I am not writing. Other is USCG. USCG stands for United States Coast Guard. These are some of the prime agencies looking after the American side, and on the international you have what? You have MARPOL. Then you have your SOLAS, etc. All these rules have to be complied with. So, like this you have a set of governing certifying agencies, and their inspectors and come and approve your design. That is, all the drawings that you will be doing in the general arrangement drawing, they have to be approved by all these people. So, you have to be constantly, when you go into or employed in one of these offshore companies, you also have to have a rapport with the people or inspectors from these certifying agencies. Anyway, so because you are dealing with oil, so oil actually creates more problems if you oil and natural gas. Now, topsides are actually centered around these facilities. Topsides design. So, these are some of the certifying, and on top of that you have the minerals, and there is another US Mineral Management Service. So, MMS stands for, this is in the US, this is US Mineral Management Service. So, fortunately, most of the Indian shipyards, they are not building your offshore platforms, neither large oil tankers, especially if you are building offshore platforms for the US or tankers for the US, you are asking for trouble in our country. So, that means you have to, the tanker or the platform has to conform to all these codes. So, that will shoot your cost. Indians are not accustomed with all this, isn't it? So, relating with the surveyors from these, in our country most of the survey work is done by ABS, Lloyds, then also you have dual survey with IRS. Okay. So, that means you are familiar with these kind of people, but these peoples, they are very exacting if you are building any vessel for the US. So, remember that, and that is why you will find the Japanese, Koreans, now also Singapore has come, they are more efficient in building all these structures. Most of the offshore structures you will find they are built in Singapore. So, topsides design is centered around number 1, prevailing wind direction. So, this normally you do not care in ship design, isn't it? Why? We will come to that. Because of the spread of fire. So, prevailing wind direction, now this is studied normally from a diagram which is called a wind rose. I will give you a diagram of a wind rose, prevailing wind direction. So, I told you most of these structures are erected because to prevent the spread of fire. So, you have to erect firewalls. And barrier walls. So, normally in the ships you will not find all these firewalls and barrier walls. Next you have process flow. You have to have sufficient piping to enable process flow to your various pumps, compressors and all these things. Safe work areas. So, normally the crew or the personnel on board, they will not like to be exposed to two things. One is risk of fire, isn't it? So, you will not like to go too close to a equipment which suddenly catches fire, ignites. Number 2 is what? So, these are the two frightening aspects for human safety. Number 2 is motions. So, human beings, they are very much susceptible to motions. You will feel more seasick. Your platform, especially for floating platforms, you will find they are always having the surge motion. Surge and heave is continuously rolling and pitching. You can restrain by mooring, but to some extent the platform will be having surge and heave motion. So, that will cause motion sickness, so sea sickness will come. So, that means the personnel on board will not like to work. So, after a few days you will become homesick and try to leave the platform. So, that is why personnel on working on platforms, they are given extra money. A large sum of money is given to them because of two things. One is the risk factor and the other is the environment. Because of the environment, you get the unsafe working environment. So, safe work areas have to be designed. Then you have problems in ventilation. Now, why? Because the accumulated gases should not accumulate in closed areas. So, you are dealing with natural gas. So, you can see the pockets of natural gas collecting in certain corners. So, they are the potential sources of fire and explosion. So, that means you have to drive away all these gases. So, ventilation is another very crucial area, and in the event of fire taking place, you have to devise suitable escape routes. So, normally in ship GA, you will find after you have segregated all the areas for cargo accommodation, engine room, they basically first to calculate the volume and then you design the areas or the volume design. What about this escape routes? Another important area for naval architecture or ship designers is your escape, or sometimes this is called a access plan. Access plan has to be shown in your GA drawing. You are designing a large ship or offshore platform. Now, all the enclosed areas and spaces have to be assessed, isn't it? Personnel should be able to go and operate the equipments or for other service. So, suitable access plan has to be done. So, here actually naval architects, you see I have found in shipyards, they are not very good at the access plan. Access has to be provided to all the areas. Escape routes. Next is firefighting or firefighting equipments. Now, you have to decide on two things: the nature of the equipment and also the number of these equipments and location where you are going to locate them. Firefighting equipments are numbered. First one, you will have fire extinguishers, now fire actually in ships also you come across, there are two types of fire extinguisher. One is the portable variety and the other is the non-portable one, or called a fixed fire extinguishers. There is a particular installation you have the extinguishers. So, anyway, that is talking about that will take a lot of time. Number 8 is what? Thermal radiation. Now, why this is taking place? Because of gas flare. So, you are igniting the gas which is coming from while you are recovering the oil, so that is ignited in the flare stack. So people should not go near that, and at that place you will find large amount of heat is coming onto the platform because of the flare from the stack. So the other one I have already told you is vapor dispersion, that is the inflammable vapor or the poisonous vapor has to be dispersed by good ventilation. This is related to your ventilation. So deck design, topsides design. The other one is if you have future expansion. Suppose you want to have drill more wells or production facility has to be enhanced, you have to have segregated area for that. You have to keep aside the area. The last category is quite troublesome. This is called simultaneous production and drilling. So this will actually increase your deck area because of the difference in the nature of the equipments which are related to production and drilling. So your deck area design has to take care of all these activities. There are 11 in nature, and the two basic decks are what is called the integrated deck, and the other is the modular deck. Now in the integrated deck, so you have to decide which one is going to be installed in the platform, whether you are going for integrated deck and the other is a modular deck. Now two important considerations are installation. Normally you will find that the deck is installed on the platform after you have located the underwater structure on the seabed, and this depends on, there are two methods by which this is done. One is called the floatover method. This we will come talk about later on, and the other is called hookup method. Now floatover method you will find they are actually done by barges. So your deck is actually carried, that is the integrated deck is carried on barges, and then they are positioned on the jacket. Okay, that is called the floatover method. The hookup method is the modular construction where deck modules are actually taken up by the cranes and positioned on the deck of the platform. So that is called the hookup method. Now coming to the integrated deck, here you will find you have a main deck, or sometimes this is called a main upper deck. Now this function of this deck is supports drilling production systems. This is the main function. And what are the others? Drilling production systems, then you have utilities and living quarters. This is called the main upper deck, similar to your the ship. Now on top of that you have another deck. This is called a cellar deck. This is similar to your twin deck in cargo ships. This is called a cellar deck. Now this actually supports support systems at a lower elevation. Now, previously I talked about the air gap requirement. You come across that. So, that means the decks also has to be positioned at a certain elevation over the mean sea level. That means such that your waves do not come and crash on the deck, isn't it? Otherwise, there will be havoc to your person on board the vessel. So, this is called a cellar deck, and these support systems needed to be at a lower elevation. Now, these are examples you can write. These are pumps. Then you have Christmas trees, production Christmas trees. Of course, Christmas trees in case of floating platforms, they are not positioned on the deck, but on the seabed. But for fixed platform, you will find these are to be on the deck itself. Then you have wellhead manifold. Manifold is where the pipes are connected to a structure. This is called a manifold. So, some of these are some of the equipments on cellar deck. Now, what has happened nowadays is that the decks previously were of the open type, that is the truss type, but nowadays you are going for closed type of deck in order to give buoyancy when the structure actually any accident occurs, or to give righting arm the stability. So, anyway, the cellar deck is positioned, and you may have additional decks. So, these are called mezzanine deck. To house process equipment. Yeah, these are some of the cases of integrated deck. Now, the modular one, you have the other variety is called a modular deck. So, this is quite an interesting study. Now, as naval architect, you have to decide on what before we discuss modular deck. Anyway, modular deck is consists of, first one will be a module support frame. So, that means here the deck is split up into number of modules which are hooked up by cranes, and then it is placed on the deck. Now, obviously, those single items are to be positioned at a particular area on the deck which has to be strengthened. That is why you have to have a module support frame. So, this is actually a space frame structure supporting deck modules. Space frame supporting deck modules. Now, next you have the modules, the different modules. So, one is a module support frame, that the different deck modules that are to be supported are living quarters modules. Then you have utilities modules. So this actually houses power generation, other equipments, etc. Then you have wellhead. One word. And the last one is drill rig. So you have to have separate modules, and these modules are actually carried by your offshore cranes and positioned on the deck on the module support frame, right? So these are to be taken care of. And there are two more modules. One is the production module and compression module. So these are compression modules. I think it takes care for compressors for gas injection. Compressors for transferring gas to shore. So this is required. Production module is production. This basically comes for piping. Piping is also a very important contribution to your ships and offshore structures. I don't know whether you have learned something about piping. In offshore, piping is tremendous. So piping and control systems. And these, of course, you have. So these are some of these, and I think I require one more class, or after the mid-sem finish and start with your moorings. Now the thing that is required is how many decks and extent of deck area. That is the design requirement. So deck design, you have to do two things. One is horizontal and vertical. Horizontal space requirement, and there is vertical space requirement. Follow.